So I told you that the basic operating principle of generator is your electromagnetic torque, it must oppose the mechanical torque, right? And this is the prime most condition for energy conversion from mechanical to electrical in case of generator, right? The same principle we have discussed in DC generator, right? So here also the electromagnetic torque is opposing the mechanical torque, right? And due to this opposition, your mechanical energy will be converted into electrical energy in case of synchronous generator, right? That is the basics of electromechanical energy conversion in case of synchronous generator. So now, since this electromagnetic torque is opposing to this mechanical torque, that means prime mover, it will face retardation momentarily, right? But in order to supply the load, if you want to feed the load, the speed of this prime mover, or you can say the speed of this rotor, it should never be less than the synchronous speed, right? So in order to maintain the constant speed, in order to supply the load, the speed must be maintained constant, right? And for that, it should draw some more mechanical energy from the input side, right? See what I said, again I repeat, this electromagnetic torque is opposing this mechanical torque, right? So now rotor will slow down momentarily. Suppose the load has increased, and due to this opposition of this load, this opposition of electromagnetic torque to mechanical torque is increased. So now the rotor, prima facie, it appears to slow down momentarily, right, for very small time period, right? But it will not it will not remain in the same condition. It will not remain in the same condition, and this, as soon as it faces any decrement in the speed, this will allow the steam valve to open, and now some more mechanical energy will be given by the prime mover, right? And again the speed will be maintained constant, which is equal to synchronous speed, right? So the amount of electrical load that has been increased, the same amount of mechanical input it will take, and this is only possible when electromagnetic torque will oppose this mechanical torque. You understand now? Suppose now further electrical load is increasing on this synchronous generator, then what will happen? This electromagnetic torque will now further oppose this mechanical torque, and the same amount of mechanical input it will draw from the steam input side. It will further open the steam valve, it will further increase the mechanical input power, and it will thereby maintain the speed of this prime mover always constant, right? And at the end of the day, this electrical power output must be equal to mechanical power input in case of synchronous generator, right? So you understand now? So this is the basics of electromechanical energy conversion from mechanical energy to electrical energy in case of synchronous generator, right? So you understand the operating principle now? At the end of the day, your electrical power output must be equal to mechanical power input. And what is the speed of this rotor? The speed of the rotor is always and always synchronous speed, that is given by ns is equal to 120 f by p, where f is a frequency 50 hertz, right? F is a frequency 50 hertz and p is the number of poles, right? F is a frequency which is equal to 50 hertz and p is the number of poles on this machine, right? Now, so this is the basics of electromechanical energy conversion. That means electromagnetic torque must oppose the mechanical torque. Okay, so that's how the energy gets converted from mechanical to electrical in case of synchronous generator, right? So I told you that synchronous machine, it always rotate at synchronous speed, right? So a speed of this rotor, it will always be equal to synchronous speed. Ns is equal to, which is given by Ns is equal to 120 F by P. Ns suffix s denote the synchronous speed. So your rotor will always rotate at synchronous speed, and it is irrespective of the loading condition, right? From no load to full load, you vary any load, it will always rotate at synchronous speed only. And let me tell you that at the same synchronous speed, your air gap flux will rotate, right? At the same speed, at the same synchronous speed, your flux will rotate in air gap between this rotor and this stator, right? I have already explained this, right? So the synchronous speed is that speed at which your rotating magnetic field is rotating in air gap, right? See here, I have already explained this. This is your cut section model of synchronous machine, right? So here, see this, we have taken a cylindrical rotor. So between this stator, see this green colored figure, right? So this is a stator frame, and here this is the rotor, right? In between this stator and this rotor, there is gap, right? This is called air gap, right? Which is basically uniform if it is a cylindrical rotor synchronous generator, right? Because of the shape, because of this structure of this cylindrical rotor, this air gap is uniform. And let me tell you, this uniform air gap will improve the performance of this synchronous generator, which is having the cylindrical rotor, due to this uniform air gap, due to this structure of this rotor. So once the air gap is uniform, the flux distribution will also be uniform, and consequently the EMF generated will be sinusoidal, mostly sinusoidal, right? And that's what is desired for power generation. For power generation, the EMF must be pure sinusoidal, and that you are able to achieve this due to this cylindrical structure of this rotor. So here I just want to explain that there is gap between a stator and this rotor, and in this air gap your rotating magnetic flux is rotating at a synchronous speed. And here I have explained that the rotor will also speed at the same speed, right? Rotor will also rotate at synchronous speed in air gap, right? Because this is a synchronous speed, and speed of this rotor will never be less than the synchronous speed, and definitely this rotor and the rotating magnetic field both will rotate at synchronous speed in air gap, right? So you have understood now why this is called synchronous machine. The reason is, the primary reason to call this machine to be synchronous machine is that the machine, when it will be connected with grid, it must be synchronized with the grid frequency. That's why this is called as synchronous machine. And also its speed of the rotor, it will always be synchronous speed, and it will not vary from no load to full load. So this machine is called as synchronous machine, right? And you know, my dear friend, that since the rotor is also rotating at synchronous speed, and your rotating magnetic field is also rotating at synchronous speed in air gap, that means the speed of both is same, which is equal to synchronous speed given by n is equal to 120 by p, so you will not find any concept of slip, right, as you have studied in case of induction motor, right? Induction motor, the operating principle is different, right? I have already explained that. But here, since both the rotor and the rotating magnetic field, rotating magnetic flux, they are rotating at synchronous speed, so that's why this machine, you will not find here any concept of slip, right? So here rotor will always rotate at synchronous speed, right? You understand now? So this is the operating principle of synchronous generator. And for energy conversion from mechanical to electrical in case of synchronous generator, it this magnetic torque, it must oppose this mechanical torque, then only the energy conversion is possible from mechanical to electrical, right? So this is the basics of generator operation, right? You understand now? So let us go further. So okay, so thank you very much, thanks for watching.